Hey friends, just wanted to give you a quick overview of what is autoimmune hemolytic anemia, standing for AIHA, and then what is warm and cold hemolytic anemia and the differences between them. So remember, these are all antibody diseases, right? So they all have to, autoimmune means antibodies. So autoimmune means that there is some antibody that your body is producing against these red blood cells. So the thing with warm is that think of it as the mnemonic that first aid has was warm weather is great. So this is going to be IgG. And remember, IgG is a secondary antibody that usually is like based from the memory B cells. So you know that this is chronic conditions. It can also be due to alpha methyl dopa drug. And the chronic conditions includes lupus erythematosus, SLE. Obviously, you can see both of them in the Coombs test. So the Coombs test is going to be direct or indirect Coombs test. You can see it both of them, direct, indirect Coombs test. And of course, if you don't know what a Coombs test is, there's another video for that in the same playlist. Now let's go to cold one. So this was warm. I'm going to put it in a warm color, actually. This was warm. Warm. Oh, I'm so sorry. This was, oops, not again. Not again. Okay, warm. This was warm. And now we're going to talk about cold. So for cold, we know that this is going to be IgM. Now here's the sticky part. The sticky part is IgM and complement, okay? It's IgM and complement activated. So the sticky part here is that what happens is that it's triggered by cold and usually also cold conditions. Also mycoplasma. Remember, mycoplasma is usually seen in young males that are living in close quarters. It's the cause of atypical pneumonia, and also infectious mononucleosis. And this is from the EVB virus. And then remember that what actually happens here is that you have a red blood cell. Your IgM, I'm going to put it in cold. Your IgM is bound to it, and then eventually it triggers the complement cascade, right? The classical complement cascade. So bunch of stuff, bunch of proteins, so forth. Eventually, what happens is that you get, C1, C4b, C2b, and then obviously you get 3b, and so forth. Eventually, when red blood cells inactivate the complement, right? Red blood cells are happy they inactivate the complement. But the C3b eventually, what happens is that it can trigger, it's an opsonization. So they eventually, then you obviously go ahead and then you actually have a whole bunch of other factors and you form the MAC. Red blood cells will inactivate the RBC. They will inactivate the MAC complex. How are they going to inactivate it? Remember that all red blood cells have an anchor protein in them. Here. They all have an anchor protein. And then on top of that, they have a whole bunch of factors. You're going to remember this from something that you studied, which was paroxysmal nocturnal hemolysis, right? This is when the red blood cells have a GP1, and then they have DAF protein. So what color we're gonna put it? They have a whole bunch of proteins here, like sorry, that was too thick. Okay, like DAF. They have CD59, CD59, CD55, and these are all proteins that cut the complement, right? So think of these proteins as a big cutters. They inactivate complement. However, you will have some residual C3b left over. And this C3b is an opsonization. It tells the splenic macrophages that, hey, it's time to it's time to eat these red blood cells and you get spherocytes instead. So this is why what usually happens is that the complement does not work at cold temperatures. So remember, complement does not work at cold temperatures. Cold temperatures, no complement. However, when eventually what happens is that IgM gets, it gets disassociated from the cell. You have C3b residue, and this residue no complement. However, so the thing to remember that in cold temperatures, IgM is bound to your red blood cells and it's inactivating the complement. However, when you get hot temperatures, such as the core temperatures, remember the blood is circulating around your body, right? And then when you have when it goes to your core temperature, which is always going to be higher, cold temperature in the core organs, IgM goes away, falls off, and C3b triggers complement, and of course splenic macrophages triggers complement, and spleen phagocytosis, resulting in extravascular hemolysis. So hopefully this kind of gives you an idea about the cold and the warm hemolytic anemia. Remember, warm weather is great, so it's going to be IgG. Usually it's a sign of chronic conditions, and it's usually in hot, in warm temperatures, and also can be induced by alpha-methyl-DOPA. Cold is IgM, and complement. Cold autoimmune hemolytic anemia is triggered by IgM and complement. Usually cold conditions, mycoplasma, infectious mononucleosis, these are associated with cold hemolytic anemia. And basically what happens is that the IgM gets on the surface of the red blood cells, makes this whole complement cascade, makes a MAC, which is a membrane attack complex. However, healthy red blood cells also have GPI1, DAF, CD59, CD55. They all inactivate the complement. So in cold temperature, there is no complement formation. However, when your blood circulates and goes to the core organs, the IgM falls off. However, there's still residue C3b, and that C3b triggers complement, and then it tells your spleen to do phagocytosis and hemolysis. So hopefully this gives you a good overview. Wish you all the best in your study. See you later.